All right, thank you very much. Cool. Hi, everyone. So, to start off, I'm June. Recently, I've been working on a distributed matchmaking algorithm for Unreal Engine, and this is basically where all the game clients coordinate with each other using like free online lobbies, like with Steam or EOS, and basically let you do team-based matchmaking. So, as a developer, you can say, "Oh, I want 4v4 or 3v3v3, and you can queue up parties or solo queue players, and it basically just all figures it out without you having to run a matchmaking server. The thing is, this is a distributed algorithm, which means testing it is kind of difficult because you basically need to run clients. Now, I do have some unit tests to do some very quick testing, but you really need to know like how does it behave when you put it on a real backend with real players with like lots of parties and over time as well, because the backend might have like for EOS or Steam, they might have outages, and you want to test how the algorithm responds to error codes. So I put together this neat little continuous functional testing system. This dashboard is supposed to live update, but some of the previous clients stalled out. So I thought I'd do a bit of a deep dive in how this kind of works. So as you can see on the matchmaking monitoring page here, this is a historical graph of all of the clients that queued up into matchmaking, whether or not they got into a match that was filled, or whether or not there was errors, or whether they were partially filled. And it also keeps track of any error codes and log files from each client. So I can go in and have a look at basically how things went. Well, those logs aren't loading right now. But yeah, so that's what it looks like from the front end. So how does this actually work? How does it fit together? So to start off, on the Unreal Engine side of things, because that's basically what we're going to be doing, we use a commandlet, which is written in C++, and this is a way of running Unreal Engine without actually launching the game. So you can write code, you can launch the game binary with a commandlet. It won't actually run the game, but instead it'll let you do your own custom code within like an Unreal Engine context, where you can just run your own code. So this is fairly straightforward, basically logging into the EOS backend, then joining or creating parties, and then we're kicking off the matchmaking progress either as the leader of the party or as one of the other party clients. And then we're basically getting this the progress events and the complete events here. And then we're basically taking all the data and we're putting it out as JSON onto the console. Next up, we have a little test harness script. And what this is doing is this is sitting inside. So this is all going to get bundled up inside a Docker container. And we're basically piping the output of Unreal, and we're parsing each of these log lines. So for just the general logs, we're just dumping them as is, but then we're looking for these specially formatted lines here with the matchmaking results. We can parse a JSON out and then send the results back to the monitoring server. This also involves using a little C# library that does gRPC communication back to the main server. Initially, it was HTTP with JSON, but because of the amount of log data we're sending, that just didn't really work very well, so it ended up being gRPC. So we bundle all of that up inside a Docker container. That's just basically building everything together, and then we deploy it into... So we don't actually deploy this container into Kubernetes. We push it up to the registry, and then because what we want to do, we don't just want to run a bunch of test harnesses and run them once. We actually want to continuously launch them. So we have another script, which is also going to get bundled into its own container. And what this does is it basically sits here in a loop. And it's basically figuring out a delay, which varies over time. And then it's basically just generating the YAML for each of the pods that it's going to launch, which is going to be our test harness, using the test harness image, sorry. And then it basically just does, it just applies it into Kubernetes. So what you get is, if we look at the Kubernetes cluster, we can see that here's the stream pod that has that script that's sitting there in a cycle, and here's all of the pods that it's launching, the test harness things, and these are running all of our Unreal Engine clients. So that's how basically we spin up all the clients, and then on the actual monitoring side, we have a where I've got that's the streaming Docker file. Trying to get through quite a bit here. So, and then we have our monitoring server. This is basically just an ASP.NET Core with React project. Fairly straightforward. The only thing that's kind of a bit interesting or novel here is Oh, I've got 15 seconds. Cool, that's actually pretty good timing. Yeah, as I mentioned before, gRPC, and then we just ingest the logs. It has Postgres on the back end, and we use SignalR to push the WebSocket notifications down to the client, which it would be doing if it had installed. All right, hopefully I covered everything.
It's pretty cool. Like, yeah, it's a lot of solutions to get that done, but yeah, I can see how handy that is. How long did it take you to figure all this out?
This monitoring system probably took a couple weeks on and off, I think. Yeah, because it's kind of a thing where I would leave it overnight, and then I would come back the next morning and it'd be like, oh, it stopped, or it broke, or whatever. Yeah. And like, for example, right now, where it's not making any progress for some reason. So, yeah, so it's kind of just... But that's also kind of the point, is just to like let it run, because I'm going to find errors both either in the monitoring system or in the algorithm that I'm only going to see by continuously functionally testing this over time.
My other question was, what was the biggest challenge in this one? Because there's lots of small hurdles I see.
The getting the network communication from the test harness up to the monitoring server was a real pain. So as I mentioned, it started out being JSON requests to HTTP over HTTP, sorry. But that was just too much overhead for the amount of, because it's also sending all of the log data up, not just the stats. That was just too much overhead. And then I went to JSON over TCP, so I would just open a TCP socket. But for some reason, after a while, it would just randomly start like not getting the latest messages. So you'd have clients sitting in this thing here being stuck on like, oh, I'm still processing, like waiting for players or whatever. But the container had actually like finished, got a result. It was all good. Just the message hadn't come into the server. And then the last one was like, okay, I'll try and do gRPC. And then there was a whole bunch of problems with like proxying that through Cloudflare and stuff, which was just pain as well. So it's basically that was the hardest part. Yeah.
Awesome. Thank you so much. I'm sure like there's a whole bunch of questions I'm sure people have, but yeah, I'm kicking you out. Thank you so much.
Okay. June. Thanks for having me.